All right. Hello, everyone. I am Mayank Kejriwal, and today I am delighted to be presenting on a topic that is something we are actively researching in our group, which is large language models and knowledge graphs. And we want to know whether they are friends or they are foes. So that will be my goal for this talk. So, a little bit of an introduction. So, I am a research assistant professor at the University of Southern California. I hold joint appointments in the Department of Industrial and Systems Engineering and also in the Information Sciences Institute. And what you see here on the right hand side are some of the projects that we work on in my group. So, we work both on applied projects, e commerce, healthcare, AI for social good, but we also try to understand the fundamental properties of AI and especially AGI, artificial general intelligence. That has become a very big topic. So these are just a snapshot of my projects. Um, but we work a lot on applied AI and foundational AI. So a lot of things I'm going to be telling you about are influenced by these real world projects. So, just wanted to quickly acknowledge some of my collaborators. So, a lot of the work that we do is very collaborative. It takes a village to do the work, and I want to acknowledge both our funders, but also the universities and organizations that we work with in the research that we do. So let me jump straight into telling you what a knowledge graph is. Now, I'm not going to tell you what a large language model is because you have most likely heard of that. If you have heard of Chat GPT and you've heard of Bard and so on, these are large language models. So we all know what they are. We've played with them, so they don't need any introduction. But a knowledge graph is something that a lot of people have not heard about, but it's very easy to understand when you look at what it is. So there is a formal definition, but I will not tell you the formal definition. You don't need to know it. You can just see what's on the screen in front of you, and this is really what we mean by a knowledge graph. So some properties that I want to point out. So a knowledge graph contains entities. So these would be, Bob Dylan here, Steve Jobs, United States. Now entities can have different types. So an entity could be a person like Bob Dylan, could be a country like United States, could be a location, could be a song, could be anything. So entities can have different types. Entities can have attributes. For example, Bob Dylan has a gender, birth date, family name, and so on. And entities are related to other entities. So Steve Jobs is a fan of Bob Dylan. Bob Dylan lives in United States, and so on. So when you think about even this very simple visual data structure, it contains a lot of knowledge. It's in graph format, and it contains knowledge about a domain. In this case, it's encyclopedic, pop culture kind of domain, but the domain could be medicine, it could be government, it could be anything that you can think about. So uh, as long as we have knowledge about the domain, we can express it using a graph. Now, knowledge graphs, which are also sometimes called knowledge bases or KBs, which are historically the preferred term, have a long history. And in fact, when you look up papers in Google Scholar, you'll see that there are papers going back to 1989, 1993, and even earlier. And people have been trying to use AI, artificial intelligence, and natural language processing for building these knowledge graphs and knowledge bases because they are incredibly useful. Now, you might ask why KGs? Why are they so useful? And the idea is that here's the problem, right? For machines. So we humans, we like natural language data. So if I give you, a document, you can read it, you can understand it because you understand the language. Um, in the same way, when we see images, that kind of data is very easy for us to understand. But for a machine, what is better is the structured data that you see on the left, which is this very rigid sort of relational database, structured database. And KGs are kind of in the middle. They are supposed to provide structure to the machine because it's a graph, but it's also very readable because, as you just saw in the example I showed you, it doesn't look like a database. It's very intuitive. Steve Jobs is a fan of Bob Dylan. Bob Dylan lives here. Bob Dylan has this gender. Bob Dylan has this birth date. Bob Dylan is related in other ways to other things. And so it's kind of really intuitive. And for the more machine learning practitioners, you can also do graph machine learning on a knowledge graph, which is quite powerful. So knowledge graphs are trying to offer you the best of both worlds, both natural language readability, so more intuitive, but also the kind of structure that a lot of machine learning algorithms really need. And knowledge graphs are also more interpretable, they are more explainable, they contain your data in a symbolic way, which makes it easy to visualize them, to understand them, to debug them. And by the way, you have seen a knowledge graph before, even though you may not have actually realized it. So if you have done a search in Google, such as the following, which is, places to visit, San Jose, it used to be the case 10 years ago, 12 years ago, that you would not have seen all these things that are, highlighted over here. You would see a list of web pages, and you still see a list of web pages when you do a search. But these days, you don't even click on the web page because you can see all this other stuff that will answer your query in a lot of cases. Where is this coming from, right? How does Google know that you are looking for exactly this, or that the San Jose is a city, or that you might be planning a trip to San Jose, or there are other cities that are related to San Jose? Well, because what Google is really doing is that it's understanding through its knowledge graph that San Jose is an entity. It's the name of a city, and places to visit is a set of entities, which are the tourist locations that are in San Jose. So somehow, magically, through years of engineering and other things within Google, they have managed to treat this query not just as a string, but as something that is meaning. And the search engine, through the Google Knowledge Graph, can try to understand this query and give you answers that you see over here. So there is a Google Knowledge Graph, and I encourage you to look at the YouTube videos on the Google Knowledge Graph. It was pretty revolutionary 10 years ago when it was integrated into Google. And beyond Google, the knowledge graph has been used in many other companies. So LinkedIn is known to have one, Amazon has one called the product graph. An open source knowledge graph is Wikidata, similar to Wikipedia. Wikidata is a crowdsourced knowledge graph where you can go in and add facts and entities, just like you can edit and add things to Wikipedia. So this is openly available. You can download it and use it for all kinds of applications. The others are not openly available. They are proprietary because they are within private companies. Um, so how do we get these knowledge graphs? Right. So usually the knowledge graphs come from natural language data. So you have some corpus, right? So you see that over here, corpus slash raw data. This could be natural language documents. It could be reviews, like when you buy the product and you place a review. So, those are short texts, but they are still natural language. It could be social media. It could be YouTube comments, it could be news articles, it could be manuals, and so on. It could be anything, but there's a corpus of raw data. And with multimodal knowledge graph, it could be image and video also. But right now we will stick to text. And you also have to define your model, right? So you need to know what is in your domain. So if you are in the medical domain, then you will define things like protein, gene, and so on. And those are the entities that you care about, right? So all of this is happening in the semantic web community. There's a big body of work on this. And then once you have this ontology, the schema, then you want to extract the entities from the natural language. So this is information extraction, named entity recognition, and so on. After this step, you get an initial knowledge graph, as you see over here, figuratively. There's an initial knowledge graph that you get from the raw data. So we're kind of, if you remember that smiley face that I showed you, that the knowledge graph is in the middle of structured and unstructured data. We're kind of going from natural language slowly to the knowledge graph, right? So we get this initial KG using NLP techniques. But this initial KG is noisy, right? So there could be duplicate nodes. So these are entities that are extracted across multiple documents, but are in fact the same entity. So President Trump, Donald Trump, etc. These are all the same entity, but they are represented in slightly different ways in the natural language, right? So they need to be reconciled. This is where we use graph mining, where we want to use the knowledge discovery, data mining, machine learning to infer missing links, to remove noisy links, to do duplicate detection. And we call this KG identification, but because at the end of it, you have a complete knowledge graph. You have a knowledge graph that is clean. Then you put this inside a database infrastructure. We call this a graph database, and then it's open to applications. Um, so this is actually quite complex, right? If you think about it, there are many boxes in here. Each one of the boxes is an entire area of research in its own right. So it's no surprise that it's in the big companies that we are seeing these kind of knowledge graphs being built. But right, and so the landscape is complicated. There's statistical techniques, NLP, etc. There's also ontological techniques from semantic web. But the LLMs, ChatGPT, right, has really changed the game. And what we now believe is that the large language models might be able to replace some of these boxes, or at least make it really easy. So you don't have to engineer an information extraction solution. You don't have to engineer the entity resolution solution. So LLMs are a friend to the knowledge graph in the sense that they can replace some of these components and make it easier to build knowledge graphs. So this is one side of the equation. However, there is another thing to think about, which is that can LLMs replace knowledge graphs altogether? Do we need knowledge graphs anymore, or can we just replace them with LLMs? On this question, the community is very divided. There are some who believe that knowledge graphs are not necessary. We can just replace them with LLMs. There are others who believe uh, that LLMs have problems, and we know they have problems such as hallucinations. They can make things up. They sometimes are very confident about knowledge that they do not have, and so we would argue that for things like truth and fact checking, for scientific text mining, for recommenders, maybe a knowledge graph still can play a very major role, because we need the knowledge. We cannot just trust the LLM to give us the knowledge. We need some independent representation of the knowledge. But definitely in some of the problems, like question answering and summarization, the LLM has replaced the knowledge graph. So it used to be the case that the state of the art solution would use a knowledge graph for question answering and for summarization. But by now, the LLM, such as ChatGPT, has completely replaced the summarization and question answering. We don't need knowledge graph anymore for that. But for some of the other things like truth and fact checking, scientific text mining, recommendation systems, we see both. So there are knowledge graph solutions, there are LLM solutions, and the jury is still out that do we can we fully replace knowledge graphs with LLMs? Now, what we believe in our group, so our belief is that they should both coexist in support of the application. So yes, in some applications, LLMs will dominate. There are very few applications where LLMs cannot be used. I mean, I can't think of anything really. So, there's going to be no application that is not going to be touched by LLM if it involves text, which is absolutely fine. But we do believe that only LLM for an application is actually problematic. And so one area of innovation is that can we query graph databases more intuitively? So for those of you who have taken a database class or who have played with graph databases, querying these kinds of databases is not easy, right? So here you see a query that is written in this language, right? And you have to know the language, you have to learn the language. It's like learning a programming language. It's a little bit like SQL, but not quite. And what this query is saying is that we want to know all of the actors who have acted with Tom Hanks, and then we want to know all the actors that are co-actors of those actors. That's quite complicated, right? It's kind of like saying that, okay, let's find the list of actors who have acted with Tom Hanks, right? So that will be a set of actors, and then we want to know who all the co-actors of those actors are. Give me the list of that. So how many actors are 2 degrees separated from Tom Hanks? That's what we're really asking. And if we can say that, if we just tell a language model or some system that, okay, give me all the actors who are 2 degrees of separation away from Tom Hanks, that's the ideal way that we want to express the query, right? We don't want to write something like this because we have to know what the model is. We have to know how to write this language, which is too much to ask. So what we are trying to address is that can we, state something like this, which is name the Oscar-winning movies that Tom Hanks co-actors have acted in, and if we ask this to the LLM, it will give some answers, but it can also hallucinate. So some of the movies may not, in fact, be the movies we are looking for. We don't know what the reason is. It could be the movie too is Oscar winning, but it doesn't have Tom Hanks co-actors in it. It could be that the movie has Tom Hanks co-actors in it, but is not Oscar winning, right? And there may also be movies that are Oscar winning that have Tom Hanks co-actors but are not listed. So there are three problems that can occur. And how do we know that the LLM is actually doing well on this? Because it does make things up. Most of the answers are correct, but there will be some of these problems once in a while. So what we are instead thinking is that if we send a question to the LLM, but now the LLM will convert the question to the query, and then we will issue the query against a knowledge graph and then get the movies. Then we believe that because the knowledge graph contains all the information about these movies, we can actually we can get all the answers we want and we won't get wrong answers. So we believe that the two need to actually coexist together. Now this is the vision. How do we actually do this is something that we have made a lot of progress on, but but this is really cutting edge research. Everyone is trying to figure this out. So this is kind of our vision. It's very simply expressed, which is that we want the graph database, we want the knowledge graph, but we don't want to learn how to query it. We want the LLM to be like a translator that takes our questions, converts it to the query, and then issues it against the knowledge graph. So that's one of the things that we are looking at. Um, and there are many applications for this. One is healthcare. So this is an actual architecture that we are working on with Kaiser Permanente, which is a major healthcare company here in the US. And the idea again is that the user, we don't want the user to be able to understand how to write queries. So instead of the user issues a queries that, okay, give me the best pediatrician open on weekends, then all of this fancy stuff happens under the hood, where the user issues this question, the question gets converted to the query, and then the query is issued against the knowledge graph, and we get back the answers. And because we trust the knowledge graph, we can trust the answers. We are not depending on the LLM to give us the answer directly. The LLM will only convert the question to a query, but the answers are coming from the knowledge graph. So that's kind of the thing to remember here. So I'll close out by saying that there are many synergistic opportunities for KGs and LLMs. I've just shown you one of them. LLMs could help minimize social friction and improve collaboration. It's also easy to use them. They are very good performance, and there are many complex solutions that could be framed as LLM prompting. So we are really excited about this because we believe that building knowledge graphs and querying knowledge graphs will become very easy because of LLMs. So we see LLMs as friends, not foes. Although in some applications, LLMs have replaced knowledge graphs. So in some applications, they are not foes but conquerors. So they are either conquerors or they are friends. They are not really foes. And so if you're interested in learning more about knowledge graphs and about other things, these are three books. This is a textbook on knowledge graphs. The right-hand one is my latest book, which is meant more for industry professionals and executives, where I talk about AI for the future. We are also planning to launch a free HTML version of this knowledge graph book, which will contain addendums on large language models, because the book came out before the large language models had come out. So we are, do watch out for that. You don't have to buy the book. You can actually follow our HTML when it comes out in a few months. And with that, I will stop here. And do feel free to connect with me on LinkedIn. And thank you for attending. And I was delighted to be here and to contribute to this session.